Hey guys, yeah, today's class is going to be based on circle theorem series 3. So we have done series 1 where we introduce ourselves to the properties of circles and every part of the circle you need to know. And then the second series was to talk about and in the first series I think we treated the theorem that has to do with the line drawn from the center of a circle to bisect a chord which is not a diameter. So and then the second theorem the second series we talk about some theorems that has to do with cyclic quadrilaterals, and then you can check out the videos in on a channel. So this third series, which is series 3, we're going to discuss the theorems that has to do with tangents to a circle. So if you watch the first series, you should know what a tangent is. So a tangent is just a line that touches circle from external points. So suppose I have a circle. So the circle is this, and then any line drawn from external points to meet the circle or touch the circle from external points is called the tangent. So this is the tangent. Anyway, it's different from a secant. A secant will cross the circle like this, while a tangent will hit the circle from external points. So that is what we're going to talk about. So the theorem that we're going to discuss will be based on those ones that has to do with the tangent alone. So now let's go through this. So I'll call this any name of my choice or any number. I'll give it a number. I told you the theorem number is not meant to be remembered. They are just for references. So now what we need to do is, let's take for instance, or whatever the number I must have given to the theorems I've discussed before. So we can just call this maybe theorem whatever. So now here, if I call it theorem 1 as far as this video is concerned, so then I have this, then a tangent like this. Okay, let me redraw the circle. So you have this, pardon. So now this is a tangent. So meeting the circle at point T. So let's say this is T. Then the center of the circle is center O. Now this theorem we want to talk about tells us that so when a line is drawn from this point, which is the center, to meet the point of contact of that tangent with the circle, it is always at right angle to the tangent. So which means that this line, which happens to be the radius of the circle, is perpendicular to the tangent TA. So if TA is a tangent, TA is tangent. So R, which is the radius of the circle, is perpendicular to TA. So that is what the theorem is talking about. So which in the case that the angle here is going to be 90 and also the one here will be 90. So we have various questions that will come out of this. I can just sketch a diagram of one of it. So let's look at this. So suppose you have the tangent, then you have the radius of the circle, and then probably you have something like this. So this property could be used to find the length of the tangent T, A, or probably the length from here to here, and at the same time the radius, because this happens to be what's called a right angle triangle. So you make use of Pythagoras theorem. So which means OA squared would be, this is R. So R is the same thing as OT, but let's put it as R. So R squared plus AT or TA, let's put it TA squared. So this is one property. Another property about this is I think you've gotten this straight away. So another property is probably you have some questions that comes this way. This is the tangent, and then you have something like this. So anyway, this happens to be 2 radius. Then it could come this way. How when you meant to find maybe this angle or this angle, or you'll be given whatever this angle might be. So now this shows you have an isosceles triangle. So this is center O. So the angle here x would be equal to here. So and then knowing that here is 90, here is 90. So which means if I put this as y, I would say y plus x equals to 90 degrees. And at the same time x equals x because the triangle here is a right angle, is a isosceles triangle. So and the radius here is equal to radius here. That proves that is an isosceles. So and then once you got this angle, you can find this, or probably you find this. You have this, and you're going to find this or this. Okay, take for instance when I give when I was given this angle to find this angle. If I'm given this, I know the sum of this plus this is 90. So then I will have to find my x first, knowing that my x is equal to this, is also equal to this. So then I have 2. Then add it together, subtract from 180, which is the sum of angle in a triangle. I'll be able to get this. So these are various questions, though we can have, this is not the limit of all the questions you might see on this particular theorem. We can have tougher, hard, or more technical questions. So now let's look at another theorem. Maybe we just discuss basically just 2 of it. So and then we talk about the scenarios where you have to use them, just like I did for this one. So now, let me call that theorem 2. So if I call it theorem 2, and what is the theorem? Now the theorem says that if you have a circle and there are tangents from external points, so let's assume we have a tangent here. Oh, sorry. We have a tangent here. Then you have another tangent here. So what the theorem is trying to tell us is that these tangents meet at the same point. So let's say that is T. Then you have this to be A and you have this to be B. So the theorem tells us that the length of the tangents are equal. So far they meet at the point and they are touching the same circle. So which means TA is actually the same as TB. So don't forget, so if you draw a line from this point of contact, though this is not drawn to scale, a tangent should touch the circle at a very small tip, so not as deep as this. So but just pardon my drawing. So then you have this and then this. So that happens to be the radius of the circle, r and r. Another property you have to understand here is that here you have a triangle. So this is a right angle, this is also a right angle. Don't forget from the first theorem. So it proves that here is 90 and here is also 90 and here is also 90. So and at the same time, if you have an angle here, this and this are the same value, then also these and these are the same value. Okay, let's make that theta. So equal angles here, equal angles here. So many questions can come in such a way that you have to apply them. So we have varieties of theorem that has to do with tangents here. So but I will discuss one more property of tangents, and especially when it involves 2 circles. So now one part is, I just want to explain this property. Now when you have 2 circles touching each other, that means they are forming tangents to each other. So you can have 2 circles touching themselves, either big or the same size. So now when this circle touches themselves, don't forget this, we have a radius, small r, and this we have a radius, big R. So each circle serves as tangents to each other. So which means the length from O to O prime, that is O to O prime, must be the sum of the 2 radius of the circle. And this could even take place within the big circle, like you have something like this. It is possible. They still form tangent to each other. So this would have, let's say this is 2 radius. This is the small one. And if you join this with this, you have the big radius here, r. So which means from this O to this point T, So OT, let me put it this way, OT should be R, yeah, that is R, the whole R. So which means the small r is gonna be OT minus, this is OT, which is R. So to get a small r, you just have to subtract this, the radius of the small circle, from the, okay, you want to get this distance, you just have to subtract the radius of the small circle from r. You get the distance between the centers of the circle. So you can use this property because this is center 1, center 2. So from C1 to C2 would be r minus r. So this is another property. So, and there are some questions where you just have a tangent touching the circle altogether like this. So in this case too, we have a lot of theorems you can use. So this and this, from the first one, you know, here is 90, here is 90. And you could even draw a line like this. So where you have your right angle, then whatever you want to find, you could find it from there. So just know that this is small r, this is big R. So, and this is r, big R equals small r. So to find the length of this, let's call that x. You can find x using r plus r squared plus r squared. That is this. R plus r squared, that is opposite, then this is adjacent, r squared. So these are the properties of tangent to a circle. So if you have any difficult question that you think we can solve, just like you'll be preparing for your UTME exam or whatever exam, being your O levels, or maybe questions that are beyond the O level, you can just put them down in comment section. So in the next video we give a touch to the question, we give it a try so we can learn together. Thank you for watching. Please subscribe to the channel, it's free. Thank you.